Pluto is a far-off and secretive smaller planet that was once an individual member of our solar system. However, recent alarming declarations by leading astrophysicists Neil deGrasse Tyson and Mito Kaku have brought Pluto back into the spotlight with a stunning disclosure. They proposed that this frosty world is on a potential impact course with Neptune. But how could this work out, and what might be the outcomes of such an enormous event? Are we seeing an intriguing galactic peculiarity, or is there something else to this looming inestimable crash? Join us as we investigate the potential outcomes of a Pluto-Neptune collision. Pluto, a former planet that was downgraded to a dwarf planet partly because of its unique orbit, remains a subject of interest and study in the galactic community. According to recent predictions by leading researchers, Pluto's orbit is dangerously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Mito Kaku are both raising the alarm about a potential hazardous crash between these two planets, which could pose a gigantic threat to Earth. How is such an event even conceivable? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It requires a stunning 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even completed one full revolution. But the interest doesn't stop there. Pluto's orbit is marked by its highly elliptical shape, straying considerably from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unique is its inclination, calculated at 17 degrees to the ecliptic plane. The way Pluto follows its path is much steeper compared to the other planets. This inclination and eccentricity add layers of complexity to its orbital pattern. One of the most fascinating aspects of Pluto's orbit is its intersection with Neptune's path. For about 20 years in each orbit, Pluto actually draws closer to the Sun than Neptune, challenging what we might expect from their positions in the solar system. This prompts the natural question: why hasn't Pluto crashed into Neptune? The answer lies in the gravitational effects of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers tried to figure out its unique path. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and elliptical shape. The mystery deepened with the realization that Pluto's orbit does, in fact, cross Neptune's. The stability of Pluto's orbit amidst these complexities is evidence of the intricacies of space mechanics. The three-body problem in space involves determining how three objects in space, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. In Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complex way. The terms axial libration and scope libration, along with the VSK oscillation, are part of this puzzle. According to astrophysicists, what keeps all planets in their orbits is AEL libration. With regard to Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is crucial in keeping their orbits from intersecting. Scope libration, on the other hand, refers to the vertical movement of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is positioned far above their orbital plane, providing an extra layer of protection from potential collisions. Another critical aspect in this situation is the VSK oscillation, named after three researchers, Zell, Kai, and others who studied how objects move in space. It involves the way three space objects, like Pluto, Neptune, and the Sun, pull on one another with their gravity. This pulling influences how they move. For Pluto's case, the VSK oscillation helps us understand why its orbit near the Sun is so unusual. Despite Pluto's path seeming irregular, this oscillation helps keep it moving smoothly over long periods. The VSK oscillation shows that even though things in space seem chaotic and unpredictable, some patterns and rules keep everything in order. All of these factors help keep Pluto's orbit stable, ensuring that it doesn't crash into Neptune or stray off course. This three-body problem is key to understanding how these orbits change because of the way space objects pull on each other. Studying this helps us learn more about Pluto and our solar system, as well as distant worlds and their stars. Mathematical simulations in the late 1980s revealed that despite these stable properties, Pluto's orbit is actually turbulent, with minor deviations in initial conditions leading to significant differences over thousands of years. However, these extraordinary properties of Pluto's orbit have been found to maintain stability over incredibly long timescales, effectively keeping the turmoil in check. Recent computer simulations have helped us understand how large planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a unique connection with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This relationship helps keep Pluto's orbit consistent. However, Neptune isn't the only one at work. Jupiter's gravity also plays a large role in safeguarding Pluto's orbit. Additionally, Saturn helps as well. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a steady path for a long time, even millions of years. So it's as if Neptune, Jupiter, and Saturn are all working together to ensure Pluto continues to move safely in space without running into trouble. These phenomena are essential for maintaining order and stability in space. Without these mechanisms, the solar system as we know it would be a much more chaotic place. Bodies like Pluto could collide with others or be ejected from their stable paths, triggering a chain reaction with other celestial bodies. For Pluto, especially with discussions about it potentially colliding with Neptune in the future, understanding its orbit is crucial. This gives a clearer picture of the dynamic nature of the solar system. The case of Pluto demonstrates how even the most seemingly unstable orbits can reach a state of balance through the complex interaction of gravitational forces and orbital mechanics. It also shows the importance of continuous observation and investigation of these phenomena to better understand our place in the universe. Exploring the depths of space often leads us to confront the strange nature of celestial bodies, and Pluto's orbit is a prime example of the unpredictability. The concept of orbital chaos, which refers to the sensitive dependence of a celestial body's orbit on its initial conditions, is clearly illustrated in Pluto's case. This means that even slight changes in the dwarf planet's position or speed can significantly alter its long-term orbit. Using computer simulations has been immensely helpful for scientists in figuring out how Pluto moves in space. These simulations use complex math to model how Pluto and other space objects like Neptune pull on each other. By tweaking small details in the simulations, astronomers can see how even small changes can make a big difference in where Pluto ends up. In the late 1980s, these simulations showed something interesting about Pluto's orbit. Even though it has mechanisms like AEL libration and scope libration to keep it stable, its orbit can still be unpredictable and erratic. If you start with just a small difference in where Pluto is or how fast it's moving, its orbit could end up looking completely different after a number of years. But even with this chaos, Pluto's orbit remains stable over super long periods, like billions of years. This means that Pluto's journey around the Sun has a kind of order to it, even though it seems chaotic at first. Predicting celestial events, especially when they involve turbulent orbits like Pluto's, is a significant challenge. The inherent unpredictability of these systems means that long-term forecasts are often filled with uncertainty. While mathematical models provide powerful tools to understand and predict the future paths of celestial bodies, they also highlight the limits of our predictive abilities. These models depend heavily on the accuracy of initial conditions, and any small error or distortion can lead to vastly different outcomes, making exact predictions a daunting task. Moreover, the chaotic nature of planetary orbits like Pluto's reminds us of the ever-changing and dynamic nature of the universe. While we've made huge strides in understanding space, Pluto's case reminds us how much our knowledge of the universe still remains limited. Understanding the gravitational effects of the giant planets on Pluto's orbit provides valuable insights into the broader dynamics of the solar system. It shows how the presence and position of each planet can have sweeping effects on the stability and direction of other bodies within the system. So why are major astrophysicists just now raising concerns about a potential impact between Pluto and Neptune? Despite all these complex forces trying to prevent such an event from occurring, Neil deGrasse Tyson, a prominent astrophysicist and a significant figure in popularizing cosmology, offers a unique perspective on the mysteries of our solar system, especially the intriguing case of Pluto. Tyson, known for his role in the renaming of Pluto from a planet to a dwarf planet, offers insightful analysis on the evolving nature of celestial mechanics and the public's fascination with the unexplored realms of space. Tyson's position on Pluto's renaming is based on the ever-expanding knowledge of our solar system. He views the renaming not as a downgrade, but as a necessary adjustment to our growing understanding of the many bodies orbiting our sun. Tyson's approach to celestial mechanics is one of continuous learning and adaptation. He sees the complexities of orbits, such as Pluto's, as a sign of how much there is still to discover in space. The intrigue of these unknowns is what keeps the exploration of space so exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a picture of a dramatic future. In a recent interview, he addressed the threat of a potential collision with Neptune, stating that while the chances of this event occurring in the near future are minimal, it remains a possibility over long timescales. He described this scenario as a fascinating yet unsettling possibility for humanity, emphasizing that such an event would be catastrophic. So what exactly might occur if Pluto did collide with Neptune? The consequences of such a dramatic event would be both incredible and terrifying. First, Pluto's icy surface and small size mean that a collision with Neptune could produce intense heat and possibly vaporize Pluto. Given the immense size and gravitational force of Neptune, such an impact could send debris into space, causing ripples in the surrounding orbits of moons and asteroids. The collision might also have more far-reaching effects, possibly even altering the paths of other planets or asteroids. Moreover, if Pluto were to collide with Neptune, the gravitational impact could alter the trajectory of both planets, creating a domino effect that would reverberate through the solar system for millennia. If such a collision were to happen, it might trigger a chain reaction of collisions throughout the solar system. Smaller bodies like comets and asteroids might be displaced, and their trajectories could bring them closer to Earth. This would heighten the risk of cosmic debris impacting our planet. While such a cataclysmic event seems far-fetched, the unpredictable nature of space means that no outcome can be completely ruled out. The prospect of Pluto and Neptune colliding raises fascinating questions about the stability of the solar system. While the mathematical models suggest that their orbits are kept relatively stable due to the complex gravitational interactions at play, these systems are not completely immune to change. Even slight shifts in the distribution of mass, such as the influence of distant passing stars or the gravitational effects of yet undiscovered objects in the outer reaches of the solar system, could eventually destabilize these delicate orbits over millions or even billions of years. What also remains a mystery is the full impact of these unpredictable cosmic forces on bodies like Pluto, which reside in the far reaches of our solar system. The outer planets, Jupiter, Saturn, Uranus, and Neptune, are immense, and their gravitational pull extends far beyond what we can immediately observe as they subtly influence the movements of bodies in the Kuiper Belt, Pluto's region. These forces could cause shifts in Pluto's orbit, potentially making it more erratic and vulnerable to future collisions. The possibility of an unseen planetary body or a rogue object passing through the outer solar system could trigger orbital disturbances. These dynamics make predictions about Pluto's future particularly challenging. In our current understanding, Pluto's orbit appears stable, but we cannot rule out the occurrence of perturbations that might arise in the distant future. Astrophysicists continue to use advanced simulations to model long-term interactions and to identify even minor instabilities that might lead to significant changes. However, as simulations show, even a tiny alteration in the mass or position of a celestial body can ripple out and affect the larger system over time. These subtle effects could potentially make Pluto's orbit more erratic and increase the chances of an impact with Neptune or another planet. In addition to gravitational interactions, we also must consider the role of orbital resonance. This phenomenon, observed in many parts of the solar system, occurs when two bodies exert regular, periodic gravitational influences on each other. Pluto and Neptune are currently in a 2-on-3 resonance, meaning that for every 2 orbits Pluto completes, Neptune completes 3. This resonance helps maintain the stability of Pluto's orbit and prevents the two bodies from colliding, even when they come close. However, over very long periods, resonances can evolve and shift, potentially making such a collision more likely. Moreover, the potential for new discoveries is another factor that could alter our understanding of Pluto's future. As astronomers continue to probe the distant reaches of our solar system, They may uncover new objects or even another planet that could influence the orbits of the outer planets. A new discovery could lead to new gravitational interactions that would change the predicted stability of Pluto and Neptune's paths. One important consideration in the study of Pluto's orbit is its long-term evolution. While the current stability of Pluto's orbit is a product of gravitational interactions, these interactions may not last forever. The solar system is constantly evolving, and as planets continue to interact with one another, minor changes accumulate over time. Given the vast timescales involved, even small shifts in the positions or velocities of celestial bodies can eventually result in drastic changes. This gradual evolution suggests that while the risk of a Pluto-Neptune collision may be low in the short term, it remains a possibility in the distant future. Thus, the eventual fate of Pluto and Neptune will depend on a complex interplay of gravitational forces, orbital resonances, and the unpredictable nature of space. The research into this topic is ongoing, with astronomers keeping a close eye on any emerging factors that could shift the dynamics of these distant orbits.